Hi guys, welcome back. In the last session, we started our discussion related to Kubernetes deployments. So in the Kubernetes, there are several important concepts that we need to understand, right? We have started, these are the important things that we know that we should learn in the Kubernetes. In that we started our discussion related to pod. What is a pod? Pod is a smallest building block in the Kubernetes cluster. In the Kubernetes, every container will be created inside the pod only, right? Pods are running inside the node. In one node, we can create multiple pods also, right? And every pod will have a unique IP address. We can create the pods in two ways. One is by using interactive approach, and the second one is by using declarative approach. So in order to deploy the pods in the Kubernetes, we are using Kubernetes manifest YML. In every Kubernetes manifest YML, 4 sections will be available. One is called API version. Second one is kind. Third one is metadata. Fourth one is the spec. Okay. So here in the API version, we are specifying V1. That is the version for the pod manifest. Kind represents what you want to do with this manifest. I want to create a pod with this manifest. And in the metadata, I'm giving the name for the pod and I'm giving label for the pod, right? Name is different and label is different. Labels are used to identify the pods. Service will use this label to expose the pod outside the cluster. And then specification contains containers information. Inside the pod, which container you want to create, by using which image you want to create the container, that we are going to specify as part of this Kubernetes manifest specification. Right? Next one. Here I'm telling this name should be used for the container and this image should be used for the container creation. So this image is available in my Docker Hub. This is a public image. So here Kubernetes will download my image and will deploy. I'm telling that what is my container port. My container port is 8080. This is Java web application which will run in the Tomcat server. Tomcat port number will be 8080. After this, we have seen what are the pods running by using a command called kubectl get pods command we are using. kubectl get pods command will give you what are the pods that are running. You see, there is one pod is running in from last 23 hours. And similarly, we can go for kubectl get a service. What is the service running? The service is running from last 22 hours. So Java Web App Service is running with a node port. And the node port number, it has taken random port number as 30785. So get ports and get service that we are able to see. If you want to check the details of the pod, kubectl get pods -o wide. It will give you the pod, what is the pod IP and what is the node that pod is running. In which node the pod is running and what is the pod IP that we can see by using kubectl get pods -o wide. So this is my pod manifest. In order to see the pods which are created, we can go for kubectl get pods command. If you want to create the pod by using manifest YML, apply -f, that YML we are going to give. If you want to describe the pod, kubectl describe pod command. To check the logs of the pod, kubectl logs with the pod name. Get pod running on which worker node. If you want to see the pods which are running in the worker node, then you will go for get pods -o wide. Whenever we create a pod, the pods are running inside the cluster. So for every pod, we will have one IP address. But here, guys, we can access the pods only inside the cluster. So the pods are created in one worker node. My pod is created. So this pod can be accessed only within the cluster. We cannot access the pods outside the cluster. So here, in order to expose the pods outside the cluster, we are going for a concept called service concept. Okay. So now to expose pods, what is the main purpose of the service? It is used to expose the pods. What are the services available? One is a cluster IP, and the second one is a node port, and the third one is a load balancer. So like this, there are three types of services available in the Kubernetes to expose the pods. Now, for example, for my application, I'm creating 3 pods. For my application, I'm creating 3 pods. So let me call it as pod 1 and pod 2 and pod 3. 3 pods I have created, and every pod will contain its own IP address. Every pod will contain its own IP address. Got it. Now, when the pods are created, 3 pods are created in the 2 worker nodes. Assume that first 2 worker nodes created in first 2 pods created in the first worker node, last pod is created in the second worker node. Okay, guys. So there are 3 pods are available. There are 3 pods available, and for every pod there is a IP address. For every pod there is a IP address. Now we can access the pods with IP address within the cluster, but not outside the cluster. Okay. Now what I want to do is, I don't want to access the pods by using pod IP because pods are ephemeral. Pods are ephemeral. Nothing but pods are short-lived objects. Pods are short-lived objects. So pods, currently 3 pods are available. Out of these 2 pods, 1 pod may get crash. 2 pods may get crash. Okay. Now, so when the 2 pods are got crashed, another 2 pods are created to replace them. Self-healing capability available for the pods in the Kubernetes. When one pod is deleted, another pod will be created. When the new pod is created, the new IP will be generated. So that's why we should never access the pods by using pod IP. The reason, pods are ephemeral. Ephemeral, nothing but short-lived objects. Short-lived objects. When pod is recreated, IP address will change. When pod is recreated, IP address will change. So that's why it is not recommended to access the pods by using pod IP. Okay. We need to expose the pods for outside access using Kubernetes concept. We can't access pods outside. In order to access the pods outside using Kubernetes service concept. So here, first thing that we need to understand, pods are ephemeral. Pods are short-lived objects. Pods will be recreated for the application. Now, if there is some problem with the pod 1, then pod 1 will be deleted and new pod will be created. When the first pod is deleted and a new pod is created, pod IP will be changed. So that's why we are not going to use the IP address of the pod to access them, because pods are short-lived objects. Pods will be recreated several times. So pod IP will change when it recreated. Pod IP will change when it recreated. Pod IP will change when it is recreated. That's why we should never access the pods by using IP. So to expose the pods, to access the pods, we are going to use 3 services. What are the 3 services? One is a cluster IP, second one is a node port, and the third one is a load balancer. Sir, here, what is the meaning of a cluster IP? For all the 3 pods, instead of using the pod IP, I'm going to generate one cluster IP. That means to access the pods within the cluster. So instead of using the pod IP, I'm going to generate a service by using cluster IP. When I use a service cluster IP for the pods exposing, what is the advantage? For all the pods, one IP address will be generated. All the pods will be mapped to one IP address. For example, the IP address is generated like this, 192.168.1.1. Like this, one IP address is generated for the pods, and this is a cluster IP address. Now, every pod is having its own IP, but we cannot use the pod. We should not use the pod IP. Why we should not use the pod IP? Pods are ephemeral. What is the meaning of that? Pods are short-lived objects. What is the meaning of short-lived objects? Several times pods will be recreated when there is a problem. When the pod is recreated, its IP address is going to change. So we should not depend on the IP address of the pod to access them. So I want to get one unique IP address. That IP address should not change in the future. I want to access my pods. For the pods, IP is available, but I don't want to use the pod IP because it may recreate in the future. So that's why I want to generate one common IP address to access all the pods. So that's where we are going to expose the pods by using a service called cluster IP. So what is the meaning of a cluster IP? Cluster IP nothing but for all the pods, one IP address will be generated. Within the cluster, we can access the pods. Within the cluster, we can access the pods. So if you expose your pods by using cluster IP service, those pods are accessible only within the cluster, not outside the cluster. Are you guys able to follow me? So without cluster IP also we can access the pods. But the problem, you need to use the pod IP. When you use the pod IP, if the pod is recreated, IP address will change. There is a challenge here. So that's why if you want to access your pods within the cluster, we will expose the pods by using cluster IP service. When you go for a cluster IP service, what will happen? It will create one IP address to access our pods. See, a cluster IP service will be created. That service is mapped to all the pods that we have created. Now, in order to access the pods, instead of using pod IP, we can use a cluster IP. Cluster IP is a static IP. It will never change. If this pod is deleted, no problem. Cluster IP is not going to change. This pod is also deleted, no problem. Cluster IP is available. Another pod is created, no problem. Cluster IP will not change. So any pods that you want to access only within the cluster, then we are going to use cluster IP service to expose the pods. Okay, guys. Now suppose I want to access pods outside the cluster also. If you want to access the pods outside the cluster also, then you need to go for either node port service or you need to go for load balancer. Node port service available and load balancer available. By using node port service and load balancer service, we can access the pods outside the cluster also. Cluster IP means the pods will be accessed only within the cluster. Guys, please concentrate carefully. Please concentrate. These topics are difficult. It will take time to understand. I'm repeating multiple times. Please give your attention. Then only you will understand the Kubernetes. We are deploying the pods. So when we deploy the pods, pod will have an IP address. By using the pod IP, we can access the pod only within the cluster. But we should not use the pod IP to access because in future pods may be recreated. Pods recreation means IP address will change. So old IP will not work for the new pod. So that's why if you want to access the pods only within the cluster, we need to expose them by using cluster IP service. How to use a cluster IP service? If you go to your service manifest file, in the service manifest file, here we are specifying type as a node port. Instead of the type as a node port, we can specify the type as a cluster IP. Now save it. After saving this, let me go for kubectl apply -f Java web app service.yml. kubectl apply -f that service.yml. Okay, when I go for that, my service is configured as a cluster IP. So verify how to access that service. kubectl get service. When I go for kubectl get service, can you see my Java web application service is created. The service type is a cluster IP. The cluster IP is the cluster IP service is having a IP address. Cluster IP service is having a IP address. Where we can access this IP? Can I access this IP address outside the cluster? Can I access that from my browser? No, that is not possible. That IP address we cannot access outside of the cluster because it is a cluster IP. Now, if I'm trying to access that cluster IP outside, it will not be accessible. Cluster IP nothing but it will be accessible only within the cluster. Cluster IP nothing but only within the cluster. Now, cluster IP service. When we are going for cluster IP service, when we create the pods, every pod will get unique IP address. Unique IP address. We can access pod inside cluster using its IP address. But pods are short-lived objects. When pod is recreated, its IP will be changed. So we can't depend on pod IP to access. You got the problem? We are creating the pod. The pods are having unique IP address. We can access the pods within the cluster using its IP. But the problem is pods are short-lived objects. When pod is recreated, its IP will be changed. So we can't depend on pod IP to access that. So to expose the pods within the cluster, to expose pod access within the cluster, we can use cluster IP service. Cluster IP service will generate unique cluster IP will generate one IP address to access our pods within cluster. Cluster IP will not change. When pods are recreated. Okay. So we are exposing the pods by using a service called cluster IP service. When I expose the pods by using cluster IP service, for all the pods, one cluster IP address will be created. You can see here, one cluster IP address got created. Using that cluster IP, we can access the pods within the cluster. Sir, normally we can access the pods within the cluster now. Why we need to go for a cluster IP? Normal pods we can access within the cluster using pod IP. But when the pod is recreated, then what will happen? IP address will change. So every time you need to check what is the IP of the pod. Instead of that, I will map all the pods to my cluster IP service. When I map all the pods to cluster IP, if this pod is deleted or if the pod is recreated, no problem. The pods are binded to cluster IP. One IP address is generated. When the cluster IP is generated, I no need to bother about what is the IP address available for the pod. Because cluster IP is created. The cluster IP is a static IP. By using this cluster IP, we can access all the pods which are belongs to that. Now, how my service will identify which pods are belongs to cluster IP? That's where in the pod manifest file, we are writing a label for the pod. In the pod manifest file, we are writing a label for the pod. Label app Java web app. So this label I will give to my service to identify the pod. Okay, guys. This label I will give to my service. In my service, if you see, there is a selector. Service selector will identify, service selector should match with the pod label so that this service will understand which pods it has to map, which pods it has to expose in the service. Now, in the pod manifest file, if you observe, I have given the pod label as app::Java web app. In the service manifest, I have given selector as app Java web app. This is basically my pod label. So now here service type, I can give node port or I can give cluster IP. If I give the cluster IP, then what will happen? One IP address is generated for my pods and this service is exposing all the pods. Where we can access this? We can access only within the cluster, but not outside the cluster. If I want to access my pods outside the cluster, I need to go for service type as a node port or I need to go for load balancer. Are you guys clear with what is the cluster IP? Are you guys clear what is a cluster IP? Come on. Here I am writing comment. This is pod label. Selector should match with the pod label. Then only it will identify which pods should be exposed by using this service. Services are used to expose the pods. Now tell me when we need to go for a cluster IP service, guys. When we should go for a cluster IP service in Kubernetes. When we should go for cluster IP service to expose the pods within the cluster or to expose the pods outside the cluster. We want to expose the pods within the cluster. I don't want anybody from outside should access my pods. I don't want people to access my pods outside the cluster. I want to access my pods only within the cluster. Then we will go for cluster IP. Let me tell you a simple example. We have seen our project architecture. I want to create database container. Do you want to allow end users to access our database directly? Database I am running as a container. Do you want to access database by end users? Will you give your database access for end users? Will you give your backend API access for end user? No. What we will give for end user? For end user, we will give only front-end application access. For end user, we will give only front-end application access. So in this scenario, can I deploy my backend pods as a cluster IP, database pods as a cluster IP? So database I will deploy as a cluster IP service. When I deploy the database pods as a cluster IP service, then what is the advantage? Database pods will be accessed only within the cluster, but not outside the cluster. Database pods will be deployed within the cluster, but not outside the cluster. And my backend application pods will be available. I will deploy my backend application pods as a cluster IP service so that my backend application can be accessed only within the cluster. My front-end application I will deploy as a node port. When I deploy my front-end application as a node port, then what happens? A node port service means front-end pods can be accessed by end user. When end user access the front-end pod can access the backend pod. Backend pod can access the database pod. So these two pods I will create as a cluster IP, and this pod I will create as a node port. That means outside people cannot connect to our database directly. Outside people cannot access our backend APIs directly. Outside people can access only our front-end API, front-end project, front-end application pods can be accessed by end users. Now you got the clarity when we need to go for node port service and when we need to go for cluster IP service. I want to deploy my pods in the cluster and those pods should be accessed only within the cluster. Okay, now assume that this is my cluster. In this cluster, assume that there are three types of pods available. In this cluster, there are three types of pods available. So here, I'm going to deploy database pods. I want to run my database. Here, I want to run backend application pods. In the Kubernetes, everything is a pod. Backend application pods. And here, I'm going to deploy front-end pods. Front-end application pods I am deploying. So in the backend database, there are, assume that 4 pods available to run my database. For a high availability, I'm running my database in 4 pods. Pod 1, pod 2, pod 3, pod 4. So like this, I'm deploying 4 pods for my database. Now, here in the backend also, I'm having 4 pods. My application is running in the 4 pods. Now, backend application should access the database pods. Can we access by using pod IP? Is it recommended to access the pods by using pod IP, or it is not recommended to access the pods by using pod IP? Guys, my database is running, MySQL database is running in 4 containers. 4 containers are created in the 4 pods. Now, my backend application running in 4 pods. Can I directly establish communication from one pod to another pod by using pod IP? If I access the pod, database pod by using pod IP, then what is the problem? If my backend application is communicating with the pod by using pod IP, what is the problem? What is the problem if my database using pod IP to access the pod? Tomorrow, one pod got damaged. One pod got damaged. Then IP address will be changed. So is it recommended to access the pods with the pod IP, or it is not recommended to access the pod using pod IP? Not recommended to access the pods using pod IP. Then what I will do, all these pods will have the same label. All these pods will have a same label. For all these pods, I will create one service called cluster IP service, CIP, nothing but cluster IP. Now this cluster IP will expose all these pods. This cluster IP will expose all these pods. Now, what my backend application will do? My backend application will access the database pods by using cluster IP, not with the pod IP. Okay, when I expose the database pods by using cluster IP, database pods are accessible outside the cluster. Database pods are accessible only inside the cluster. Database pods are accessible outside the cluster. Database pods are accessible only inside the cluster with the cluster IP. Only inside the cluster. Now, there are 4 pods available for the database. Do I need to remember the pod IPs, or I need to remember only cluster IP? Do I need to remember the 4 pod IPs, or I need to remember only cluster IP? Only cluster IP. Tomorrow, 4 pods got deleted and another 4 pods got created. Cluster IP will change, or cluster IP will not change? Cluster IP will not change. Even if your pods are recreated, cluster IP will not change. Now, my backend application will connect with the database pods by using cluster IP address. Okay, my backend application is available. Backend application having 4 pods. 4 pods are having 4 different IP addresses. My front-end application want to communicate with the backend application. Can front-end access the backend pods by using pod IP, or it should not access by using pod IP? Front-end application should access the backend application by using pod IP, should not access by using pod IP, should not access by using pod IP, because my backend pods also can be recreated. When the backend pods are recreated, then what will happen? IP address is going to change. Then what I will do? My backend pods also I will expose by using cluster IP. Okay, for all the backend pods, I want one unique IP address. That IP address should not change. For all my backend pods, 4 pods available. For all the 4 pods, I want one cluster IP. Now, for my backend pods, I have created one cluster IP. When I create a cluster IP for the backend pods, then what front-end application will do? What the front-end application will do? Front-end application will access backend application by using cluster IP or by using pod IP, by using only pod IP. Now, you are an end user. Can you access my database pods directly from outside? You are outside of my cluster. You are an outside user. You are an end user. You are an end user. Now, can you access my backend pods? Can you access my backend pods? Where my backend pods are running? My backend pods are running in the EKS cluster. Where my front-end pods are running? Front-end pods will run in the cluster. Database pods are also running in the cluster. Now, you are an end user. As you are an end user, can you access my database directly? Can you access my database containers? You cannot access my database containers because they are in the cluster. They are exposed by using cluster IP. Cluster IP will give you IP address. That IP address you can access only within the cluster. Now, can my backend pods can my backend pods access database pods by using cluster IP? Guys, can my backend pods access database pods using cluster IP? Yes, database pods are running in the cluster. Backend pods also running in the cluster. Backend pods can access the database pods by using cluster IP. IP address is only one for the 4 pods. All the 4 pods are mapped to one cluster IP. One unique IP address will be available. My backend application will access the database pods by using cluster IP. So backend pods are in the cluster, database pods also in the same cluster. So backend pods can access database pods within the cluster, but outside people cannot access that. Outside people cannot access that. End user can access my backend application, or end user cannot access my backend application. End user cannot access my backend application. Now here I'm going to create 4 pods for my friend, or else I am creating 2 pods for my front-end application. I'm creating 2 pods for my front-end application. Okay, guys. Now, so here, can I give IP address for end users to access my pods, my pod one front-end pods? Are we going to give IP address for the user to access our pods, or we should not give IP address to access our pods? We should not give our pod IP address because pods are short-lived objects. Now, I want to expose front-end pods for outside access. I want to expose front-end pods for outside access. Can I go for cluster IP to expose front-end pods, or I should go for node port? Either I need to go for node port or I need to go for load balancer. Now, these front-end pods I'm going to expose. These front-end pods I'm going to expose by using node port service or by using load balancer. This node port service is mapped to these 2 pods. Now, can end user access my pods now? Can end user access the node port now? Can end user access the node port? Yes, node port means it will be available outside the cluster also. Cluster IP means it will be available only within the cluster. Now you got the clarity when to expose the pods using cluster IP, when to expose the pods by using node IP, node port, basically. Are you guys able to follow me? Are you guys able to follow me? Yes. In the Kubernetes, we are creating the pods, guys. Pod is nothing but a short-lived object. Pod is a smallest building block that we can create in the Kubernetes cluster. When you want to deploy any application in the Kubernetes, that should be deployed as a pod only. Pods are ephemeral. Pods are short-lived objects. For every pod, one IP address will be created. But when pods are short-lived, so pods will be recreated. When the pod is recreated, its IP address is going to change. So that's why we should never access the pods by using pod IP. Then how to access the pods? If you want to access the pods within the cluster, then go for cluster IP. So whenever you expose the pods by using cluster IP, one IP address will be generated to access the pods only within the cluster. If the pods are recreated also, no problem. Cluster IP is not going to change. Okay. Database pods will be exposed as a cluster IP. Backend pods also will be exposed as a cluster IP. Front-end pods will be exposed as a node port. Why node port? When you go for node port, that will provide accessibility within the cluster as well as outside the cluster. End user should access front-end pods. So that's why we will give node port service for the front-end pods. So end user should not access backend application and database. That's why backend application pods will be exposed as a cluster IP. Database pods also will be exposed as a cluster IP. Are you guys clear with my point? Are you guys clear with my point? Okay. Now guys, here, yesterday, we have created our deployment in the Kubernetes. Now, I want to delete everything, whatever I have created, and I want to do a fresh deployment. So to delete all your components created in the Kubernetes, kubectl delete all -all. Kubectl delete all -all. When I execute, kubectl delete all my pod is deleted, my service is also deleted. Now nothing is available in the Kubernetes. kubectl get pods. kubectl get pods. No resources available, no pods available. And we can go for kubectl get a service. Okay. When I execute kubectl delete all, whatever the components we have created in the Kubernetes cluster, everything will be deleted. kubectl delete all, my pod is deleted and my service is also deleted. When I execute kubectl get pods, no resources found, no pods are running. When I execute kubectl get service, my Java service is not available. Only Kubernetes cluster IP service is available. That is related to cluster, not our service. So our pod is deleted and our service is also deleted. Now I want to create the pod and I want to expose the pod by using service. Do you know how to create the pod and how to create the service? In order to create the pod and in order to create a service, we need a manifest file. Now, let me go for VS Code IDE to write the manifest files. Manifest file is a YML file. So we are going to use VS Code IDE to write our manifest files. VS Code IDE is one of the recommended IDE to develop the manifest files. Okay. Let me create one manifest YML by using VS Code. So spaces, spelling mistakes, okay, that we can understand here. I'm creating one folder, Kubernetes YMLs. Okay. Now I'm going to my command prompt and I will execute code space dot, then VS Code IDE will open. So this is my VS Code IDE. In this VS Code IDE, you can go for the extensions and you can install one extension called YAML extension. Okay. So you will get the support for the YML. If any mistakes are there in your YML syntax, it will tell you that. YML language extension will be available. You need to install that YML extension. I have already installed the YML extension in my VS Code IDE. VS Code IDE is a Visual Studio Code. This is one IDE given by Microsoft. In this IDE, we can write our YML, new file. I want to create a new file. I want to create one YML file. Okay. File, new, new text file. Let me save this file. This file I am going to save with Java web app.yml. I'm creating one YML file. In the YML file, we will have 3 hyphens and 3 dots. Okay, guys. 3 hyphens will be available and 3 dots will be available in the YML. This is the syntax of the YML. Okay, save this. So first I am going to specify my pod manifest. So here if you see API version v1 and we will be having metadata and we will be having kind. API version kind will be available, metadata will be available, spec will be available. So this is my manifest YML syntax. Okay, so API version, kind and metadata is available. Okay, version is v1, kind. I want to create a pod. Metadata, in the metadata, guys, see, when I'm writing the metadata, I'm giving one space. It represents it is a child. Name, I want to give the name as Java Web Application Pod. And I want to give the labels for the pod. You can give the label as anything. I'm giving the label as a Java Web App. Label is important here, guys. Without a pod label, we can't expose the pod outside the cluster. API version is v1, kind is the pod, metadata. Name is Java Web Application Pod. Label is the app Java Web App. Spec. Inside the specification, we are going to specify containers information. How many containers you want to create? What is the name you want to give for the container? I want to give the container name as Java Web App Container. Where is the image available? My image available in the Docker Hub account. Ashok IT Java Web App is my image name. So Kubernetes will download this image from the Docker Hub. It is a public image. You can use the same image. Then what are the ports mapping here? The ports. So here the container port The container port is 8080. So it is a Java web application. It will run in the Tomcat server. Its port number is 8080. This is called our pod manifest. So I'm writing API version, what is the kind and what is the metadata and the specification of the pod. In this pod, I want to create this container. Container name should be available like this. That container should be created by using a Docker image. And this container port is 8080. So this is a pod manifest. By using this pod manifest, we can create the pod. What is the name of the pod? Java Web Application Pod. What is the label of the pod? Pod label is Java Web App. App::Java Web App. This label is very important here. Very important. I'm writing a comment. Hash means comment. So this label is used to identify the pods to expose in the service. Okay, guys. Are you clear with my pod manifest YML? Now, in the last session, I have created one YML for the pod creation, another YML for the service creation. Generally, we can combine pod manifest and service manifest in the single YML. So here I don't want to end the YML. I want to continue the YML. To continue the YML, another 3 hyphens I am giving. So this is pod manifest. Now I will write the service manifest. How to write the service manifest? I can go for API version. Here also kind will be available. And here also metadata will be available. And spec will be available. And end it. Okay. Within the single YML, I'm writing my pod manifest. I'm writing my service manifest. I hope you already got pod manifest. Now I need to write the service manifest. Service manifest API version is V1. And what is the kind? It is used to create a Kubernetes service. What is the metadata? In the metadata, I'm going to specify the name. I can give any name for that. I'm giving the name as a web application service, Java web application service. And here, spec is the most important part in the service, guys. So API version I have given as a V1, kind I have given as a service. Under metadata, I'm giving the name as a Java web application service. Now, coming to the specification, what type of service you want to create? If you want to create a cluster IP, you can give the type as a cluster IP. If you want to expose the pods outside the cluster, you can go for a node port. You can go for a node port. If you don't want to go for node port, then you can go for load balancer. You can go for load balancer. That is also another type. So if you want to access the pods only within the cluster, then cluster IP. If you want to access the pods outside the cluster, you can go for node port or you can go for load balancer. Currently, I'm going for node port. Okay, guys. Type is the node port. Okay. I'm creating the service as a node port. But why I am creating node port? I want to expose the pods. Which pods I want to expose? Here, my service should identify the pods by using pod label. So in the service spec, we are going to write a concept called selector. Selector app::Java web app. So this is called pod label. This is called a pod label. Now I'm creating a service with the type as a node port. This service has to expose the pods whose label is equal to app::Java web app. Service is using a selector to identify the pod by using pod label. Whatever the label name you are giving here, same label you need to give in the service selector. Then only this service will expose this pod by using this label as a node port service. Okay, guys. Then after, once it is completed, then we need to go for port mapping. Internal port that we need to specify as 80. And what is our container port? That is called our target port. Our target port is 8080. What is the node port you want? Yesterday we have given 3. Yesterday we got 30785. Now I am taking node port as a 30785. Guys, writing the node port is optional here. If you don't write the node port, Kubernetes will generate one random node port number. If you want to fix the port number, then you can give the node port. So here, this is called our service manifest. This is called our service manifest. And this is our pod manifest. And this is called our service manifest. So what is the purpose of pod manifest? Pod manifest is used to specify which container we need to create, which image we need to use to create that container, what should be the label of the pod, what should be the name of the pod, that we are specifying in the pod manifest. Now, these pods we can access with pod IP, but pods are short-lived objects. That's why we need to expose the pods by using service. To expose the pods by using service, there are three types of services available. One is a cluster IP, and the second one is a node port, third one is a load balancer. When you expose the pods by using cluster IP, that will generate one unique IP address to access only within the cluster. But I want to access my pods outside the cluster. To access the pods outside the cluster, we have two services. One is called a node port service, another one is load balancer service. Now, when I'm going for the node port service, I'm giving the node port number as a 30785. That means my application ports will be exposed as a node port service on this port number. This port number I will enable in the security group to access my application. For example, if I don't write the node port, yesterday I did not write the node port, but today I am writing the node port. If you don't write the node port, what will happen? Kubernetes will generate one node port random number from 30,000 to 32,000. It is going to generate one random port number. Okay, 30,000 to 32,767. It will use, in that range, it will use one random number. I don't want that random number for my pods. I want to fix the node port. 30,785 I am giving. You can give any number between 30,000 to 32,767. Okay, this is my service manifest and this is my pod manifest. Guys, do you understand the relation between pod manifest and service manifest? Is there any relation between pod manifest and service manifest, or there is no relation? Do we have the relation between the pod manifest and service manifest, or we don't have a relation? Where is the relation between pod manifest and service manifest? Where is the relation between the pod manifest and service manifest? Pod label. Pod label we are using as a service selector. Pod label we are using as a service selector. Okay, here you can see clearly in the VS Code IDE in which line I am starting, where I am giving the spaces. These spaces are called as indent spaces. These spaces are very important. This is YML syntax. This is YML syntax. Okay, my manifest file is ready. Let's go to Kubernetes. Let ls-l. Yesterday I created web app pod.yml, service.yml. Let me remove them. rm java star.yml. Okay, ls-l. Now those files are not available. I want to create a single YML file. In that YML, I am combining my pod manifest as well as I'm combining my service manifest. Okay, take this YML, go here, create a file, vi java web app.yml, single YML file. In this YML file, I'm keeping my pod manifest and service manifest. So this is kind is pod, here the kind is service. This is a pod label, and here service selector is using pod label. Type is a node port and node port service is available. Port number I'm giving 30785. Any one number. Now, before going to do this, apply, execute, kubectl get pods. Do we have any pods? We don't have any pods. Then go for kubectl get service. Do we have any services? We don't have any Java service here. Pods are not available and my service is not available. I created a manifest YML with pod specification and service specification. Let me go for ls-l. This is my YML file. I want to create the pod and I want to expose the pod by using node port. Let's go here, kubectl apply -f java web app.yml. Enter. Now you see pod is created and service is also created. Pod created, service also created by using single YML. Now if you execute kubectl get pods, kubectl get pods. Now one pod is running, 1 out of 1. I want to create one pod. That one pod is created and it is ready and it is running. 18 seconds ago my pod is created. Let me get the service here. kubectl get service. When I execute kubectl get service, Java Web Application Service is created with the type as a node port. When you go for node port, you can ignore the cluster IP. So Java Web Application Service is created with the type as a node port. Node port number is 30785. 30785. Within the cluster, my node port is running on the 80 port number. For outside the cluster, the node port is 30785. Within the cluster, it is using 80 port. Outside the cluster, it is using 30785. Now, if I want to access my application, okay, node port number I know, but in which node it is running, where my pod is running, in which node my pod is running, how to verify that? Guys, do you know the command? In which node my pod is running? To check -o void. Okay, kubectl get pods -o void. Okay, kubectl get pods -o void. 192.168.46.198. This is the IP address of first worker node. This is the IP address of my first worker node. Now let us go to the IP address. Let us check the worker node IP and let me try to access that. So these are my instances which are running. Select this instance, first instance. In the first instance, you can see IP 192.168.46.198. My pod is also running on the same IP, same worker node. 192.168.46.198. Here 192.168.46.198. So that means in the first worker node, my pod is running. Take its public IP address and go to check the security group, node port is enabled or not. When you select this machine, check the security group. So this is the security group is available for that. In the security group inbound rule, you can check 30785 port number I have already enabled yesterday. Okay. Now let me go for this public IP :30785/Java web app. Java-web-app. Now, am I able to access my application? Am I able to access my application which is running in the worker node? My application is accessible which is running in the worker node. So now my pods are running. Am I accessing the pod by using pod IP or am I accessing by using node IP? Outside access is available. Pods are running in the cluster, but we are able to access them outside. How come we are able to access outside? Why this outside accessibility provided for my pods? How it is provided? By using node port. By using node port. Okay, guys. So do you understand what is the difference between cluster IP and node port? Do you understand what is the difference between cluster IP and node port? Yes. So when you want to deploy the pods with the cluster IP, we will specify the type as a cluster IP. Okay. Then what is the node port? Node port service is used to expose the pods outside the cluster. Node port service is used to expose pods outside cluster. Node port service is used to expose our pods outside cluster. Pods outside cluster also. Okay. When we use node port service, we can specify node port number in service manifest. Okay, guys. When we use node port service, we can specify node port number in the service manifest file. If we don't specify node port number, If we don't specify node port number, then Kubernetes will assign random node port for our service. Node port range from 30,000 to 32,767. If you don't set the port number in the manifest YML, I'm setting the node port number in the manifest YML. If I remove this property, Kubernetes will generate a random port number. That random port number range will be between this. From 30,000 to 32,767. In this range, it can take any port number to expose our ports as a node port. In this range, it can take any port number. In this range, it can take any port number. Got it? Now, pod and service, combining pod and service manifest. I have combined manifest file for pod and service specification. Combined manifest file for the pod and service. That means I want to combine pod specification and the service specification in the single YML. Yesterday we created two separate YMLs and we applied two YMLs. Today what I have done, I have created single YML. That single YML contain my pod specification as well as my service specification. Okay. Before going to execute this, delete everything delete all Kubernetes components we have created. So to delete all the Kubernetes components we have deleted, kubectl delete all all. Everything will be deleted. Apply manifest. Apply manifest. To apply the manifest, kubectl apply -f manifest file. That is our manifest YML. You can save with any name. Then after get pods. Okay. To get the pods, we can go for kubectl get pods. Get service. To check your service and the node port number. Get service. To get the service, we can go for kubectl get service. Check the pod running in which node. Check pod running in which node. So to check that, we will go for -void. Check the pod running in which node. We can go for kubectl get pods -o void. Okay. Access application in the browser. Access application in browser. Make sure node port number enabled in security group. You need to enable your node port number in the security group. So this is the URL of my application. Okay. So in this URL, what is this? It is node port number. And what is this? Node public IP, not private IP, guys. We need to go for node public IP. So with this, we are able to access our application. I use node port service. Okay, guys. Are you guys clear with my point? Are you guys clear with my point? Now you got the clarity. What is a pod? What is a service? How to create the pod? How to create the service? How to expose the pods by using service? So everything is YML based here. YML manifest files we have to write in the Kubernetes. You got it? Whenever you are writing the manifest YML, use Visual Studio Code IDE. In the Visual Studio Code IDE, install the YAML extension. Install the YAML extension so that you can see the clear spaces here and the lines where you have started, where you are ending, the clear straight lines are available. It will evaluate your syntax. Suppose if I write like this, now see, it is showing the error. When I'm not giving the correct spacing, it is giving the error. Okay. We need to give the correct spacing. Those spaces are called as indent spaces. YML will follow indent spacing. Okay, good. So fine. Yeah. So someone asking a question, if I don't give the node port number, then Kubernetes will generate a random port number. How we will know what port number it is generating? Whenever we execute Kubernetes kubectl get svc, it will show your service. In the service, you can see what is the node port number it is using. So that is the reason I'm showing the service here. When you see the service, which random port number it has taken, that you can see that port number here. So in this scenario, I'm fixing the port number. If you don't fix it, it will generate a random port. That random port we can get from this kubectl get service. Here the port number will be displayed. Okay. Yeah, guys. Any questions, anyone? Can you unmute your mic?
Ashok, what is the use of target port here? If we are using 80 port number to communicate within the cluster, and
this target port is to access our pods within the cluster. Within the cluster, pods will be accessed directly with the IP. No need to give this random node port number. Okay. So this port is 80 is used for the cluster, and this target port represents our container is running on the which port number. And for outside people, we want to give which port number. That is the meaning of 3 ports here. This is for cluster mapping. This is our container port, and this is for outside access.
Okay. Okay. Ashok, one more thing. Actually, yesterday we learned, right? We have 2 approaches to create the port, like interactive and declarative, right?
Correct.
So in one approach, we are writing the YML file, and in one approach, I think we have given one command. So why we are writing these YML if we have a simple, it seems to very simple command like this? Because
so simple commands, then generally when you are for practicing that Kubernetes pods creation, you can write in the single command. But in the real time, when we are going to automate that, right, we need to execute, we need to automate the deployment in the real time. So when you want to deploy your application, every time will you go to that system and will you type that command?
Okay. Got it.
We need to automate that by using these YML files.
Okay. And one more doubt, please. And in the architecture diagram, we have learned we have to install the Docker engine in the worker node, right? To create the container.
No, you no need to do that. Whenever you create the EKS cluster, it will take care of that.
Okay. Thank you.
So without the Docker engine, the container cannot be created, right? So whenever we execute that kubectl describe pod, kubectl describe the pod whichever running, whenever we describe that pod here, it will show you the events Java web application pod, kubectl get pods. Now kubectl describe pod. Server does not have a resource type Java web pod. What is the command I used to describe yesterday? When we use that pod describe, right, it is going to describe pod name. Sorry, kubectl describe pod name. Whenever you describe the command, what it is saying here, default scheduler assign the default pod to this particular node. So here we are sending a request to the control plane by using kubectl. Kubectl assigned that, kubectl communicated with the control plane. Control plane assigned the task to the particular node. In that node, we have a kubelet. Kubelet is pulling my Docker image from the Docker hub. Successfully, it pulled that image. Then it created a container. So in order to create the container, kubelet is creating the container. That container creation is taken care with the Docker. So whenever you create the EKS cluster, Docker also will be available in that node. Yep.
Ashok, you said that the database ports we cannot access from outside, right? So in that case, how can we access the database to see the data?
Within the cluster, you can communicate, right? In the Docker, we have seen the Docker exec-it commands we have seen to execute inside the Docker container. Similarly, here also, we can get into the Docker container. From this cluster, we can access that. Outside people cannot access that.
Oh, okay.
How we can access using the cluster IP, since you said we can use the cluster IP?
Just curl command, curl IP address. Just to see ping IP address, whether it is pinging or not, we can verify that.
In the real
we can't see the user interface here. You can just ping that IP address from within the cluster, you will get the success response.
So we need to use that particular worker node IP, which we said it is a cluster IP, because since we know worker node is that pod is running on worker node, So which worker node your pod is running? So that is the cluster IP for that pod.
No. Whenever you deploy as a cluster IP, you no need to worry about the worker node IP, because cluster IP means it will create one IP address. That IP address you need to ping.
Okay.
Whenever you create your service, whenever you create a service, so you can check the service which is created by using kubectl get svc, right? If your service type is a cluster IP, here one IP address will be generated. That IP address you can access within the cluster, not outside. When your service type is a cluster IP, you forget about the node port. You don't need that. Cluster IP means one unique IP address will be generated in the cluster. Using that IP, we can access that within the cluster. That's it, not outside.
Okay, got it. Cluster IP is different with the pod IP, worker node IP.
Yes, right.
Okay.
So I have a question regarding the database.
One person is asking how to stop the EKS cluster. You can't stop the cluster. The only thing you can do is you can delete the cluster. You can't stop the cluster.
Hi Ashok, one question.
Can I ask a question about the database deployment in Kubernetes?
The database deployment will come in the future, sir. Today, if you have any question related to cluster IP node port, you can ask.
Yeah, in the cluster IP node port also, in real world, do we need to deploy database in a Kubernetes cluster?
Some projects will use cloud database, then we no need to do that. Some projects don't want to use the cloud database, then we have to deploy the database.
Okay.
It depends upon your project architecture.
Yeah, Ashok.
Yes.
So sometimes we, after the deployment, after our API deployment, we might need to verify, API alone in the browser, right? Or in any REST API client, like Postman or somewhere. Like, how can we do that in this case if you deploy that API as cluster API?
So the REST API that if you want to access within when in dev environment, I'm talking about in the dev environment, we can deploy as a node port and we can access. When it comes to the production, we can go for the cluster IPs.
Okay.
Ashok?
Yep.
So yesterday we got an error while creating the instance. So normally we won't select the security default group, right? So yesterday while we are selecting it, we are getting an error saying that timeout. The server.
You can select the default security group. There is no problem with that.
No. While selecting the default itself, we are getting it. If you are not doing it, it is working properly. Can we use like that, or default security group is mandatory while creating?
I'm not understanding where you are talking about. In which
while creating the instance.
EC2 instance.
Yes.
Why it will give the problem?
Yeah, we are getting an error.
Yeah, so correct. Out of
you select the Ubuntu image.
Yes, Ubuntu
instance type, key pair.
So at the bottom, you can see. Yeah. Yes.
There is no error here, no?
No, we are getting an error. We are not sure why.
Yeah, then you can select this one, this security group, create new security group, no problem.
Okay. It is no problem, right?
Yeah.
Sure. We have done that. We just want to.
Yeah, no problem.
We can get these type of issues.
Sorry?
So we can create the proper network group.
Yeah, guys. So here AWS is not covered, so they don't have idea on the VPC. In the AWS classes, you will understand all the information related to all this stuff.
Yeah.
Currently, if your default group is not working, then you can select a new security group, no issue. It is just for a client machine, right? You can use it.
Okay.
Hello, sir.
Yep.
So for this node port, we are creating the YML file, right? Today you right.
Yes.
So for that cluster IP, that YML file will be different, or it will be
same. Everything is same. Just the type is going to change.
So if we create cluster IP, then what changes we need to do in the YML file?
Just you change the type from node port to cluster IP. That's it.
Okay. No other changes, right?
No. Only service type is going to be different. Even if you want to go for the load balancer, just we will change the service type to load balancer. At that time, this is not required.
And cluster IP we will get with the get svc command.
Yes.
Okay.
Ashok, what is the difference between node port and the last one, other
load balancer?
Load balancer.
That we will discuss in the tomorrow's class. Tomorrow we have a class, guys. So don't think that tomorrow is Sunday is holiday. No. So tomorrow we have a class. So tomorrow is a long session in the Kubernetes. So tomorrow I will take the class from 7 to 10. Okay. So tomorrow we have a class because our clusters are keep on running. If we run it for a long time, you will get lot of bill. So tomorrow we'll take a long session on this.
Hi, sir.
Sir, this is Prasad.
Yes, sir. Tell me.
So in our YAML file, we are giving public image. In case
Correct.
if you want to give private image, how
we'll discuss in the future classes, sir, how to give the private image there and all.
Okay. Okay. Sir.
Ashok, for Java developers, who's going to write these files and develop?
In the project, I told you, right? In some projects, developers will write these YMLs. In some project, DevOps people will write these YMLs. For the DevOps people, it's mandatory that they should be able to write this YML.
Okay.
For the developers, they don't ask much questions on the Kubernetes manifest YMLs writing, but for DevOps engineer, it is damn important because DevOps people should take care of these Kubernetes deployments.
Okay.
Yeah.
Sir, could we create the code using the interactive approach?
Sir, interactive approach, you can use it for learning purpose, but in the real time, we don't use that. In the real time, everything should be automated by using Jenkins. So at that time, Jenkins will trigger your deployment by using YML file only. Okay.
Okay, sir.
Yep.
Ashok, while creating instances, hello.
Yes.
Yeah. Manually, while creating instance, we are getting 8 GB of hard disk. So while creating it through the cubes, this thing, EKCTL, it is taking around 80 GB. So how can we change
the reason is whenever we are creating the instance, we are using T2 micro, which is a free tier instance. Here, cluster is using T2 medium, which is a commercial system. It is chargeable machine. We need more configuration for our system to run the cluster. Cluster is using T2 medium. When we create the instance, we are using T2 micro. Micro is a free machine. Medium is a paid machine. That's why we are getting more space and more RAM, more GB. Okay. Yeah.
Sir, Ashok, if we did not mention stopping the cluster bill is generating.
You can't stop it, sir. Cluster, the only option you can delete it. Once cluster is started, there is no option to stop. If you don't want the cluster, you can delete it. If you delete again, you have to create.
Ashok, if we did not mention the node port service on the YML, so are we able to access our application outside?
No, you can't access.
But I have seen we have select the public IP of that particular worker node where our pod is running and mention the port number, and we are able to. And yesterday we also did the same.
What is the service type you have used for that?
Your service type is Java Web App.
No. Type I am asking.
Type, yesterday we did not mention it. This one, no? Type.
Yesterday I mentioned node port in the service. If you see my service manifest, which I have given yesterday, I have given the service type as node port. Okay.
That's why we have accessed it.
That's why we are able to access outside. Yesterday I have given the service type node port. But yesterday you people don't know what is cluster IP, what is node port. Blindly I have given service type. Today I have given the clarity on the cluster IP and node port.
Okay, that's why I'm thinking yesterday we also did the same. Today we also did the same. So what is the node port? Yeah.
Yes, right. Today we got some more clarity on the service type. Tomorrow we'll talk about the load balance.
Okay, got it.
Yeah.
Ashok, we have cluster IP, right? How can we go to the cluster using cluster IP?
Just you can ping cluster IP address. That's it.
So that will tell just to connecting or not, right?
Just right.
How can we go inside the cluster?
You can't access that. You can't access that because it is a machine is a virtual machine. It is a CLI based machine, right?
Okay.
So tomorrow, when our backend application is there, backend application will connect with the database using that cluster IP address. We can't see our application with that IP address.
Okay. All right. Thank you.
Sir,
fine, guys.
Shall we delete the cluster or shall we leave till Kubernetes class completes, sir?
No, sir. Guys, don't delete the cluster. We need practice for next 1 week. Don't delete the cluster. If the bill is generated, no problem. We can make the bill as 0. Don't delete the cluster. If you delete it again, you have to create it. I told you very clearly. I told you very clearly. The cluster, once you create, you can't delete it. You can't stop it. You need to only terminate it. If you terminate, you can't practice it. Okay. So bill will generate 3,000 to 4,000 bill will come in the AWS, but you don't need to pay that bill amount. You can ask AWS to remove your bill and they will make your bill as 0 for first time. Okay. So all you are using AWS for first time, your bill amount will be waived off by AWS support team. I will tell you. Once the Kubernetes classes are completed, we will raise a request to the AWS team to make our bill as 0.
Okay, sir.
Ashish, why you need to delete and create the cluster every day? So don't do that. So leave your cluster like this. It will run for 10 days, no problem. 3,000 bill will come. That 3,000 we can ask AWS to make it 0. Deleting and creating every time, it will create a lot of problems, right?
Sir, for just practice purpose.
Yeah, for practice purpose.
Yes, for installing and deleting make more sense about the Kubernetes.
Yeah, if you want to do it, you can do it, but not required.
Okay.
Because it is just a single command to create the cluster, right? How many times you practice the same command, you will copy paste and you will execute.
Yes, sir.
Yeah.
Okay, sir.
Ashok, if you take class from 7 to 10, it will be 12:30 in the night in USA. So it will be not flexible for US people to join. So
yeah, we will reduce 1 hour then. 9 till 9:30 I can take.
Yeah, okay. Thank you. Thank you.
Good. Because Kubernetes is very difficult, guys, and it will take a lot of time. So I don't want to give holiday on the Sundays also till Kubernetes is completed. Okay. Once Kubernetes is completed, we can relax. Kubernetes is the most important and difficult part.
Ashok, one last question.
Yeah.
So just for practice purpose, I just terminated cluster VMs yesterday, and they get created automatically. But
yes.
But I didn't get the pod details. So I just manually run the pad this thing, YML file, then they create it.
Yes, sir. Whenever you delete the machines, right, automatically they will create. Then you need to recreate your pods.
Okay. They don't create automatically.
No.
Okay.
If you delete your machine will be recreated. Another machine will come because cluster will use auto scaling concept. So with this, what you guys understood, AWS knowledge is very important for the DevOps engineers. How the pods, how the cluster is created, how the nodes are created. If you delete the nodes, how the nodes are recreating. After our Jenkins completed, we will start with the AWS classes. Then you will get the clarity on that. Okay, fine, guys. With this, I'm stopping for today. We'll meet in the tomorrow's class. Tomorrow at regular time only we have class at 7 o'clock. 7 to 9:30 class will be there. Okay, please plan accordingly. Thank you, guys.